we are going to discuss about aldehydes and ketones. First of all, let us discuss about carbonyl compounds. Which organic compounds are called as carbonyl compounds and why they are called as carbonyl compounds? Very simple. The organic compounds which contain this type of group, this carbon is called as carbonyl carbon. The organic compounds which contain C double bond O, carbonyl carbon, are called as carbonyl compounds, or else aldehydes and ketones are collectively called as carbonyl compounds. In this aldehydes, so if carbonyl carbon is bonded with hydrogen and alkyl group, then this type of carbonyl compounds are called as aldehydes. And if carbonyl carbon is bonded with two alkyl group, may be same or different, then this type of carbonyl compounds are called as ketones. Okay, ketones. So therefore, aldehydes and ketones are collectively known as carbonyl compounds because they contain C double bond O group. This C double bond O group is called as carbonyl group, and the carbon is called as carbonyl carbon. Okay, now we will go for the nomenclature and common names and IUPAC name of aldehydes and as well as ketones. First, let us discuss about the nomenclature of aldehydes. So, the primary, secondary suffix of generally when secondary suffix is used to indicate the nature of functional group. If aldehyde is a principal functional group, then the secondary suffix of aldehydes will be Al. And if it is considered as the side chain, then prefix. The prefix, if it is if CHO group is considered as a side chain, then the name will be formyl, or you can say aldo. Okay, so if aldehyde, CHO group is considered as a principal functional group, then secondary suffix will be Al, and if it is considered as a side chain, I will write here side chain or substituent, then we have to use your write formyl or aldo. Now we will take few examples so that you can understand it very well. Now first I will start with the first member of aldehyde is formaldehyde. But here you see I said in aldehydes carbonyl carbon is bonded with the hydrogen and alkyl group except in formaldehyde. So in formaldehyde the carbonyl carbon is bonded with two hydrogens like this. Now this is formaldehyde. The common name of this compound is formaldehyde. And when come to IUPAC name, IUPAC name. Now this is the principal function group. So the IUPAC name of this formaldehyde is only one carbon is there. So therefore its IUPAC name is methanol. So why I have written meth here? Because it has only one carbon. It is having only one carbon. That is why I say I have written meth. Methanol. Now we will take one more example. The next member of this aldehyde is CH3CHO. Now the common name of this CH3CHO is acetaldehyde. And in this how many carbons are there? Only two carbons are there. So the root word is ethanol. So ethanol is the IUPAC name of acetaldehyde. So common name I am writing in the bracket, and this is what IUPAC name. So the IUPAC name of acetaldehyde is ethanol. And now we will take one more example, CH3 CH2 CHO. Here you see three carbons are there, without any side chain though. So therefore the IUPAC name of this compound is propanol. Propanol is the IUPAC name of this compound, and when come to its common name, propionaldehyde. Propionaldehyde is the IUPAC name, common name of propanol. Now we will take few more examples. CH3. Now I am taking one substituent here, CH3, and here it is a CHO. Whenever side chain is present, you know that you have to select the parent chain first. And you know 𝗬𝗏 is called as a chain terminating functional group, and you should give numbers from this carbon. So therefore it will be 1, 2 and 3. Okay, because side chain on the cavity is side chain. Okay, the name of this side chain is methyl, and it is present on the second carbon. So therefore 2'-methyl, 2'-methyl. Here how many carbons are there? 3 carbons are there. So therefore propanol. So 2-methyl propanol is the IUPAC name of this compound. Okay, now we will take one more example. CH3, CH, Cl, CH2 and it is CHO. Okay, if it is like this, now I said CHO is a chain terminating function group. When it is considered chain terminating function group, you should start giving number from that carbon. So therefore it will be 1, 2, 3, 4. And here the side chain is substituent or side chain is chlorine, and it is present at third carbon. So whenever you are writing the IUPAC name of organic compound, first of all you have to write the name of the prefix, side chain. So okay, here its IUPAC name is 3'-chloro. Yeah, 1, 2, 3, 3'-chloro, and here 1, 2, 3, 4 carbons are there. So therefore butanol. Okay, now its IUPAC name is 3'-chloro-butanol. Okay, now next when come to the common name, you know, in common names generally, okay, the carbon which is attached with CHO is called as alpha, and this is called as beta, and this is known as gamma. So here when come to the common name of this compound, 1, 2, 3. So on the third carbon, so alpha, and this is beta. So therefore beta chloro, here it is beta chloro butanaldehyde. 1, 2, 3, 4 carbons are there. So therefore its common name is beta. Here it's this is beta alpha and this is beta. Beta chloro butanaldehyde is the common name of this compound. But when come to the IUPAC name, its IUPAC name is 3-chloro-butanol. Now we will go for cyclic compounds. Say have taken this is cyclobutane, and if I write CHO here, CHO here, then the name of this this compound is a little different. You know, this is what cyclobutane, and this carbon is not included in this cyclic compound in this cycle. So therefore its IUPAC name is cyclobutane, and you know the name of the CHO group is carbaldehyde. Okay, in case of cyclic compounds like this, if CHO, this carbon CHO is not, C is not included in the ring, then you should say carbaldehyde. Okay, now we'll take one more example. Same, CHO, and here I am writing a Cl. If it is like this, you know that this one is 1, 2, 3, 4, 5, 6 carbons are there. It is called a cyclohexane, that you know very well. Now whenever it is like this, now this is a principal function group and this function group, and here you should give numbers from 1, 2 like this. So 2'-chloro, 2'-chloro, and here it is what? Cyclohexane, and I said just now CHO is called as carbaldehyde. So 2'-chloro cyclohexane carbaldehyde. Okay, is the IUPAC name of this compound. Now we'll take few more examples. Now I am taking a CH2 double bond CH and CH like this. Here it is having a functional group and as well as a double bond. You know that whenever double bond and functional group is there, you should give much priority. you should give importance for functional group. So therefore here the numbering will be 1, 2, 3. And its IUPAC name is, its IUPAC name is 2' because double bond is present at second carbon. So therefore 2' and 1, 2, 3. So 3 carbons are there. Propene, you have to remove this E and you have to write Al. So the IUPAC name of this compound is 2'-propanol. Okay, now we'll take one more example. CH3, CH2, C double bond O, CH2 and CHO. Now you see here two function groups are there in this compound. whenever two function groups are present in a given compound, then you know that you have to select one function group as a principal function group. You know that among the aldehyde, and this is a ketone function group, among aldehyde and ketone the principal function group is aldehyde. So therefore, when it is considered as a principal functional group, this should be considered as what? A side chain. Okay. Now this should be considered as side chain. Now, and you know that whenever C double bond O group, keto group is considered as a side chain, then you should write its name as oxo or else keto. Okay. So we are supposed to use oxo and or keto when this ketone, C double bond O is considered as a side chain. Okay. Now, so therefore, the name of this compound will be here, you know, this is 1, 2, 3, 4 and 5. Okay, and this keto group is present at third carbon. So therefore, 3' keto, 3' keto, and how many carbons are there? Total 5 carbons are there. 1, 2, 3, 4, 5. So therefore, it is pentanol. So 3 keto pentanol, or else in place of keto we can also use oxo. 3-oxopentanol is the IUPAC name of this compound. And you know that sometimes aldehyde function group can be considered as a side chain. Now we will take one example for that. CH3, CH, CHO, and it is CH2, COOH. Okay. Now in this compound two function groups are there. Okay, they are, this is aldehyde function group and this is carboxylic acid functional group. Among this, you know that among aldehyde and the carboxylic acid functional group, principal function group will be carboxylic acid. Okay, you know the order of priority. So among aldehyde and carboxylic acid should be considered as a principal function group. And you know that when it is considered as a principal functional group, this will be considered as side chain. And you know that whenever aldehyde is considered as a side chain, okay, just now we have discussed that when it is considered as side chain, you are supposed to use formyl, or else you can write aldo. Okay, so therefore numbering here, you should start giving number from this carbon 1, 2, 3, 4. Okay, and this CHO is a side chain. So side chain is present on the third carbon. So therefore 3 dash, you can say formyl or aldo. I am writing formyl. Okay, 3 dash formyl, 1, okay, total 1, 2, 3, 4 carbons are there. So therefore butanoic acid. And you know that whenever any function group is taken as a principal function group, for this principal function group you are supposed to take a secondary suffix. The secondary suffix of COOH is oic acid. Okay, and you know that when aldehyde is taken as a principal function group, the secondary suffix will be al. And when it is considered as a side chain, and here it is, okay, prefix is formyl or aldo. Okay, is it clear? Now we will take aromatic compound, few aromatic compounds. Okay, now you know that this is called as what? Benzaldehyde. Okay, I accepted IUPAC name, and common name of this compound is benzaldehyde, or else we can say benzene. Okay, this is benzene, and just, okay, I said CHO is called as what? Carbaldehyde, benzene carbaldehyde. Okay. Now, so we can call this compound as benzaldehyde, or else you can say benzene carbaldehyde. Now, we will take one more example. This is well known to you people, CHO, and this is OH. Okay, and its common name is ortho-salicylaldehyde. Okay, its a common name is ortho-salicylaldehyde. But when come to IUPAC name, you know, numbering 1, 2. So IUPAC name is 2-hydroxy. Okay, 2-hydroxy benzaldehyde. Okay, so 2-hydroxy benzaldehyde. So this about the nomenclature of aldehydes. Now we will go for ketones. How to write the IUPAC name and common name of ketones. So before we discuss about the nomenclature, common names and IUPAC names of ketones, we have to first will discuss about the classification of ketones. Okay, now here I am writing ketone. Ketones are classified into two types. They are simple ketones or they are also called as what? Symmetrical. Symmetrical, okay. Symmetrical ketones. Symmetrical ketones are mixed, okay. Next one is mixed or unsymmetrical. Okay, unsymmetrical ketones. Okay, simple or symmetrical ketones means the ketones in which carbonyl carbon is bonded with okay, same type of alkyl groups. Okay, or if these two are same, then that ketone is called as what? Simple ketone or symmetrical ketone. Okay, and when come to the mixed or unsymmetrical ketones, in unsymmetrical ketones or mixed ketones, the carbonyl carbon will be bonded with two different alkyl groups. Now you see this R is different and this is R dash. Okay, so bonded with, if carbonyl carbon is bonded with two different alkyl groups, then okay, so such ketones are called as what? Mixed or unsymmetrical ketones. Okay, now we will take a few examples for both simple and as well as unsymmetrical ketones. First we start with simple or symmetrical ketones. Okay, you know that the first member of ketones is CH3 C double bond O CH3. Now, you know that whenever CHO, functional group, ketone is considered as a principal functional group, you have to use the secondary suffix. And the secondary suffix of ketone is ONE, own. And if CHO, C double bond O group, keto group is considered as a prefix, I said side chain. When this group, C double bond O group is considered as a side chain or prefix, then its name will be keto or oxo. Okay, so therefore the secondary suffix of ketones is on, and the prefix, if it is considered as a side chain, then okay, its name is keto or oxo. Now here see, this is the first member of ketones, CH3 C double bond O CH3. Now here how many carbons are there? 3 carbons are there. 1, 2, 3. So prop, N, and you have to remove this terminal E and you have to write ONE. So the IUPAC name of this compound is propanone. Propanone is the IUPAC name of this compound, and its common name is acetone. Okay, and you know this acetone is used as a nail polish remover. Okay, so it can be used as a solvent and it can be used to okay, remove a nail polish remover ga use chestar deni. Okay, now we'll take one more example. Okay, say CH3 C double bond O CH2 and this is CH3. Okay, here this is the parent chain, and how many carbons are there? Total 1, 2, 3, 4 carbons are there, and here that is why its name is butanone. Butanone is the IUPAC name of this compound, or else you can write a common name like this also. No, you know that this is methyl and this is ethyl. Okay, so common name is ethyl methyl ketone. Ethyl methyl ketone. Okay, now this is a common name, but this is IUPAC name. Okay, IUPAC name and this is common name. And when come to this acetone, you know acetone is the common name, and we can write one more common name. So here CH3 is methyl and CH3 is also methyl, so both are methyl, so we can write a dimethyl ketone. Okay, so propanone, acetone, dimethyl ketone. This one is the IUPAC name and these two are common names. We will take side chains. CH3 C, CH3, C double bond O, CH2, and here it is CH3. Okay, now you know this is a parent chain, and numbering should be given 1, 2, 3, 1, 2, 3. From both sides, this carbon is getting a same number. Whenever the functional group carbon gets a same number from both sides, then in this case you should give a least possible number for the carbon having a side chain. So therefore the correct way of giving the numbers is left to right, 1, 2, 3, 4 and 5. And here what is the name of this group? You know this is a side chain and its name is methyl, and this methyl group is present at second carbon. So therefore 2-methyl. And okay, and this one, okay, you should mention the position of a keto group, because ketone is not a chain terminating function group. But in case of aldehydes, we didn't mention the position of aldehyde function group. But in case of ketones, okay, we have to mention the position. So therefore, its name is 2-methyl 3-. How many carbons are there total? 1, 2, 3, 4, 5. So 3 pentanone. Okay, now 2-methyl 3-pentanone is the IUPAC name of this compound. And you know, in ketones, if it is like this, you know that the carbon which is attached to this carbon is called as alpha, and it is called as alpha dash. Similarly, beta, beta dash. So generally alpha, beta we use in the common names. Okay, in IUPAC names we are not supposed to use this alpha, beta, gamma like that. Okay, in common names only we can use. Now we will take one more example in cyclic ketones. Okay, here you know that the name of this compound is 1, 2, 3 cyclopropane, and this carbon is included in the ring. So therefore, its IUPAC name is cyclopropanone. Cyclopropanone is the IUPAC name of this compound. We will take few more examples. So this is a cyclopropane, and now I am taking a double bond O. Here I am writing a Cl. Okay, so numbering should be given. Here it is 1, 2, 3, or else 1, 2, 3. Okay, from so both sides we will get the same number. So here its name is 3-chloro, and you know 1, 2, 3, 4 carbons are there, no? So therefore cyclobutane, and here C double bond O is there. Ketone function group is there. So therefore its IUPAC name is 3-chloro cyclobutanone. Okay, because here you see this carbon is included in the parent chain in the ring. So that is why 3-chloro, I mean cyclobutanone. And similarly you can take one more double bond O, and here this is called as what? Cyclohexanone. Cyclohexanone. Okay, now next say CH3 C double bond O, CH2 COOH is there. Now in this compound two function groups are there. What are they? Ketone and carboxylic acid function group. So among, whenever I said, whenever organic compound contain more than one functional group, in such cases you are supposed to select one function group as a principal function group. You know that among ketone and carboxylic acid, this should be considered as a principal functional group. And when it is considered as a principal function group, then this should be considered as what? Side chain. Okay, and you know that whenever it is considered as side chain, its name will be, okay, its name will be keto or oxo. Okay, therefore in this case, now numbering should be given from this side, 1 from right to left, 1, 2, 3, and this is 4. Okay, and keto group is present at third carbon. So therefore its IUPAC name is 3-keto, or else you can say oxo. 3-keto, 1, 2, 3, 4 carbons are there. So therefore butanoic acid. Okay, this is not a ketone, right? This is a carboxylic acid, because in this ketone is considered as a side chain. It is not considered as a principal function group. If it is considered as a principal function group, then only this compound is called as ketone. But here we are not considering this as a principal function group. We are considering carboxylic acid as a principal function group. So it is a carboxylic acid, but not ketone, right? Now we will take one more example. C double bond O, CH3. Okay, this is ketone, because here C double bond O function group is there. So therefore this compound is ketone, but this compound is not ketone. This is carboxylic acid. Now when come to the IUPAC name of this compound, its IUPAC name is acetophenone. Okay, acetophenone is its IUPAC name is acetophenone. Our common name is, you know, this group is called as phenyl group, and this is called as a methyl group. Okay, methyl phenyl ketone also we can say methyl phenyl ketone. Okay, methyl phenyl ketone is the common name of this compound. And now similarly you can take one more, C double bond O, like this. This is called a what? Benzo. Okay, benzophenone. benzophenone, or common name is diphenyl ketone. Okay, diphenyl ketone is the common name of this compound. Okay, whenever you are going to discuss the preparation of any organic compound, first you think from alkanes. Is there any possibility for the preparation of carbonyl compounds from alkanes? If it is not there, then go for alkenes, like that, alkynes, then benzene, then you go for alkyl halides, alcohols. Okay, like that we have to think. So there is no preparation of carbonyl compounds from alkanes. So therefore we will go for the next one, that is alkene. So the first one is from alkene. Carbonyl compounds can be prepared from alkenes. Here various methods are there. In that the first one is ozonolysis. This you learnt, this is very important, and this you learnt in the first year, ozonolysis, right? Now ozonolysis, in the ozonolysis we can prepare carbonyl compounds, aldehydes and ketones from alkenes. Okay, that process is called as ozonolysis. In this C double bond C, in the first step it reacts with ozone and forms ozonide, that you know very well, and in the second step it on hydrolysis in the presence of zinc. So this is also called reductive ozonolysis. Okay, reductive ozonolysis. So in this case, first when it alkene react with ozone, it forms ozonide. That ozonide on hydrolysis in the presence of zinc, you know that it produces carbonyl compounds. Very easy to write carbonyl compounds from alkenes. Whenever alkene is taken like this, you break the double bond like this and add O, C double bond O, like this, C double bond O. Okay, like this. Very simple. Wherever carbon-carbon double bond will be present, that you have to break like this, and you have to add oxygen, double bond O or O. Now we will take few examples for this. And before going to that, then here there is a possibility of asking question related to this zinc. What is the role of zinc in the ozonolysis or reductive ozonolysis? You know that in ozonolysis process, along with this carbonyl compounds, we will get hydrogen peroxide. You know, hydrogen peroxide acts as an oxidizing agent. So there is a possibility for hydrogen peroxide to oxidize aldehydes into carboxylic acids. So that is why, in order to prevent the reaction of oxidizing property of H2O2, zinc is used. So when zinc is used in this case, zinc react with H2O2 and it convert H2O into so the role of in this is it acts as what? Reducing agent, and you know this acts as a reducing agent and H2O act as oxidizing agent. Okay, this is the role of zinc in the ozonolysis. So that is why you are saying this process as reductive ozonolysis. We are using a reducing agent in this case. Okay, the reducing agent used in this process is zinc. Now we will take a few examples for this. How to prepare carbonyl compounds from alkenes by this ozonolysis process. Now next, H2 double bond CH2. Here I am writing O3, and the second one is hydrolysis in the presence of zinc. Just now I said wherever double bond is there, you have to break that bond and you have to add hydrogens, oxygens. Okay, you have to add oxygen. So you can write CH2O, CH2O. Or else you can write like this also, H C double bond O H, H C double bond O H. Okay, so here this is ethylene. Ethylene or ethene. Ethylene is the IUPAC common name, and IUPAC name is ethene. Ethylene on ozonolysis will get 2 moles of formaldehyde. If you want to prepare a formaldehyde, you are supposed to take ethylene. So ethylene on ozonolysis produces 2 moles of formaldehyde. Similarly, we will take one more example. CH3, CH double bond, CH2. If it is like this, okay, so you break bond, and CH3, CHO plus, here CH2 is there, so therefore it becomes HCHO. So propene on ozonolysis, we are getting a acetaldehyde and a formaldehyde. So we will get a mixture of acetaldehyde and formaldehyde. Now we will take one more, CH3, CH double bond, CH, CH3. Okay, this on ozonolysis followed by hydrolysis in the presence of zinc. Now you break bond like this. So here you will get CH3, CHO, and CH3CHO. So in this case we are getting 2 moles of acetaldehyde. So 2-butene on OH analysis gives 2 moles of acetaldehyde. 2 moles of acetaldehyde. Now if it is like this, CH3 C double bond C H and CH3, and this on OH analysis. Now you break this bond. Okay, so when this bond is broken, I said you have to add oxygen. So therefore it will be CH3 C double bond O CH3 plus CH3 CHO. Okay. Now next, so we are getting a mixture of acetone and acetaldehyde. Okay, say I have taken this compound, double bond is there, cyclohexene. This cyclohexene on OH analysis, okay, hydrolysis in the presence of zinc. Okay, here you have to break this bond. You will get CHO CHO. Okay, similarly if you take this one, double bond, this on OH analysis, you will get okay, CHO CHO. So plus CHO CHO. Okay, so now from alkenes we can prepare whatever aldehyde or ketone we required, we can prepare from alkene by this process called OH analysis. Okay, this is about OH analysis of alkenes. Okay, aldehydes and ketones we can prepare from alkenes by using one more process, that is called Walker's process. In this CH2 double bond CH2, when it react with okay, PDCl2 in the presence of CaCl2 and water. In this case you will get CH3CHO plus PD plus 2 HCl. And this process, we are using okay, PDCl2 CuCl2 and we are preparing acetaldehyde from ethylene. This process is called as a Walker process, and in this Walker process the oxidation state of this PD, okay, PD is changing from +2 to 0. Okay, so you know that the decrease in oxidation number is called as what? Reduction. Okay, so in Walker's process or in the preparation of acetaldehyde from ethylene, this compound, PD is undergoing a reduction because its oxidation state is changing from +2 to 0. Okay, this is very important. So the change in oxidation state of PD is here it is 2. Okay, now and we will take one more example, CH3 CH double bond CH2, when it react with PDCl2 CuCl2 and water, here you will get CH3 C double bond O CH3, will get a acetone. Okay, acetone you will get, its IUPAC name is propanone. Okay, so therefore aldehydes and ketones can be prepared from alkenes by using Walker's process. The first one is OH analysis and the second one is Walker process. From alkenes we can prepare aldehydes and as well as ketones, okay, by the process called as hydration. Hydration is nothing but addition of water. So in this case, say I have taken acetylene. When acetylene react with water in the presence of Hg plus 2 H2SO4, okay, now you will get CH2 double bond CHOH. This is called what? Vinyl alcohol. Okay, or it is also called as what? 2 carbons are there, ethanol, or this is a enol form of okay, vinyl alcohol. This is a enol form, and this will undergo tautomerism. Right here, CH2 double bond CHOH. Okay, this undergo tautomerism. In the tautomerism, this hydrogen will come, okay, will bind with this carbon, and pi bond will be shifted like this. So you will get CH3CHO. Okay, so acetylene on reaction with water in the presence of Hg plus 2 and H2SO4, okay, will get vinyl alcohol, and this vinyl alcohol on tautomerism, this is called as keto enol tautomerism. okay, keto-enol tautomerism. So you will get acetaldehyde or ethanol. Okay. Now the next, propyne, 3 carbons are there, triple bond is there, propyne. Propyne on reaction with water called hydration in the presence of Hg plus 2 H2SO4. Here you will get CH3 COH double bond CH2. This undergo keto-enol tautomerism. You add this hydrogen to CH2 and okay, shift this double bond, okay, between carbon and oxygen. So you will get CH3 C double bond O CH3, known as acetone. Okay. If you take propyne, you will get acetone, and if you take acetylene, you will get acetaldehyde. So I mean, so therefore carbonyl compounds, aldehydes or ketones, we can prepare from alkynes by the process called as hydration, addition of water in the presence of Hg plus 2 and H2SO4. And one more method is there, and this is second one, B, from alkynes, that is called HBO. HBO is nothing but hydroboration oxidation. Hydroboration oxidation. Hydroboration oxidation, HBO. Okay. So in this one alkynes, or else you can say terminal alkynes, if triple bond is present at the end or starting of a compound, one alkynes. Okay. One alkynes on reaction with BH3. Okay, it exists as a dimer, you know that B2S6 is called a diborane, and the second one is H2O2 in the presence of KOH or NaOH. Okay, you will get aldehydes. We will take one example so that you can understand it well. Now, so here I am taking CH triple bond CH, this on reaction with BH3 THF H2O2 and KOH. Here you will get CH2 double bond CHOH. This undergo keto-enol tautomerism, and finally you will get CH3 CHO, acetaldehyde. Now I am taking, so if you take one alkynes, I will take one more example, CH3 CH, or like this. First one is BH3 in the presence of THF, and second one is H2O2 in the presence of KOH or NaOH. Then here you will get CH3 C, okay, H double bond CHOH, and undergo keto-enol tautomerism, and you will get finally CH3 CH2 CHO. Okay, propanaldehyde we got here, propanaldehyde. So therefore, if you want to prepare aldehydes from alkynes, you are supposed to take one alkynes. One alkynes and hydroboration oxidation, you will get aldehydes. Now, if you take non-terminal alkynes on hydroboration, first one is BH3 in the presence of THF, and second one is H2O2 in the presence of KOH or NaOH, then you will get ketones. Okay. So if you want to prepare, aldehydes, you need to take one alkynes, and if you want to prepare ketones, you are supposed to take non-terminal alkynes. Okay. Now we will take one example for this, CH3 C triple bond C CH3 like this. So this compound, you know, 2-butane, it is called a 2-butane. This 2-butane on hydroboration oxidation, it gives CH3 C double bond O CH2 CH3. So known as what? Butanone. Okay. So 2-butane on hydroboration oxidation gives butanone. 1, 2, 3, 4 carbons are there. That is why its name is butanone. Like this, we can prepare aldehydes and ketones from alkynes. Okay. We are going to discuss the preparation of carbonyl compounds or aldehydes or ketones from alcohols. The next preparation is from alcohols. Carbonyl compounds, aldehydes or ketones, can be prepared from alcohols. Now, primary alcohols on oxidation in the presence of, say, strong oxidizing agent. Then you know that primary alcohols are now oxidation in the presence of strong oxidizing. So the strong oxidizing agents are K2Cr2O7 H plus H2SO4, KMnO4 H plus. Okay. So primary alcohols on oxidation in the presence of strong oxidizing agent, they produce, they give aldehydes. And you know that these aldehydes are highly reactive, so aldehydes are more reactive, so they undergo further oxidation and forms carboxylic acids. So in this case, okay, if you want to prepare aldehyde from primary alcohols, we are not supposed to use strong oxidizing agents, because instead of getting aldehydes, we are getting carboxylic acids. So therefore, we are supposed to use, okay, instead of a strong oxidizing agent, we are supposed to use a selective oxidizing agent such as PCC, PDC, okay, PCC, PDC. PCC is nothing but pyridinium chlorochromate, NH, CrO3, Cl, okay, this is plus, this is minus, pyridinium chlorochromate, and PDC is nothing but pyridinium dichromate, Cr2O7. So PCC and PDC are used as a selective oxidizing agent. So in this, if you want to prepare aldehydes from primary alcohols, we are not supposed to use the strong oxidizing agent, we are supposed to use a selective oxidizing agent such as PCC, PDC, pyridinium chlorochromate, and PDC is nothing but pyridinium dichromate. So these are used as a selective oxidizing agent in the preparation of aldehydes from primary alcohols, and these two reagents are called as Collins reagent. Collins reagents. So therefore, primary alcohols are CH2OH. This is primary alcohol. Primary alcohols on oxidation in the presence of PCC or PDC, and solvent is CH2Cl2. In the presence of CH2Cl2 solvent, here this group will be oxidized to CrCHO. This is nothing but aldehyde. Okay. So in this process, CH2OH group, this group is converting into CHO. Very simple. So therefore, aldehydes can be prepared from primary alcohols by using a PCC, PDC in the presence of CH2Cl2 solvent. We will take one example, CH3CH2OH. This is called as ethyl alcohol. Ethyl alcohol on oxidation in the presence of PCC, PDC, here you will get CH3CHO, acetaldehyde you will get. Or if you take, say I have taken this type of, okay, I have taken CH3, CH2, CH2OH. So this N-propyl alcohol on oxidation, this is also primary alcohol. N-propyl alcohol on oxidation in the presence of PCC or PDC, here you will get CH3, CH2, CHO, propanaldehyde you will get. So the number of carbons in the alcohol will be same as the number of carbons in the aldehydes. So this is the preparation of aldehydes from primary alcohols. Now we will go for preparation of ketones. Okay. When come to the preparation of ketones, secondary alcohols on oxidation in the presence of strong oxidizing agent K2Cr2O7 H plus, KMnO4 H plus, okay, K2Cr2O7 H plus, KMnO4 a strong oxidizing agent, will get ketones. And you know that these ketones do not undergo oxidation very easily, they are less reactive than aldehydes. So therefore, in this in the preparation of ketones, we can from secondary alcohol we can use strong oxidizing agents such as K2Cr2O7 H plus, KMnO4 H plus. Okay. Now we will take one example, or else you can take this one also, CrO3 plus H2SO4. Okay, CrO3 H2SO4. This is known as Jones reagent. Okay, Jones reagent. and PCC, PDC are called as Collin's reagents, and whereas CrO3, H2SO4 is called as Jones reagent. Now, we will take isopropyl alcohol, secondary alcohol. This is known as isopropyl alcohol. Isopropyl alcohol on oxidation in the presence of the strong oxidizing agents, here you will get CH3, C double bond O, CH3. Now, I am taking a cyclohexanol. Cyclohexanol on oxidation will get double bond O. So, therefore, from alcohols also we can prepare aldehydes and ketones. If you want to prepare aldehydes, we are supposed to take primary alcohols, and if you want to prepare ketones, we are supposed to take secondary alcohols. We will take one more example. Okay, this is called what? Cyclobutanol. Cyclobutanol. Cyclobutanol on oxidation in the presence of a strong oxidizing agent. Here you will get a cyclobutanol. So, this is called as a benzyl alcohol. It is a primary alcohol. So, this on oxidation in the presence of a PCC, okay, you will get a CHO. Okay, this is called benzaldehyde. Okay, benzyl alcohol on oxidation will get a benzaldehyde. Okay, dehydrogenation is nothing but the process of removal of hydrogens is called as what? Dehydrogenation. Here, primary alcohols on dehydrogenation in the presence of copper or silver, Ag. Okay, you will get a aldehyde, or CH2OH is there. Okay, this on reaction with oxidation with copper, silver, okay, or this hydrogenation, here it removes hydrogen from this. So, you will get R, CHO and hydrogen. Okay, or else if you write like this, R, CH2OH. Now, say I have used copper and it is copper and air, oxygen. So, here you will get R, CHO plus H2. But whereas in this case, if this reaction is carried out in the presence of oxygen, here you will get R, CHO plus H2O. So, the byproducts are different. If this reaction is carried out in absence of oxygen or air, you will get the byproduct is hydrogen, and if it is carried out in the presence of oxygen or air, the byproduct is what? Water. This is very important. In the examination, there is a possibility of asking questions like this. Instead of asking the main product, they will ask about the byproducts. Okay, you have to remember this. Now, the next one, if you take secondary alcohols. Secondary alcohols are dehydrogenation. Okay, dehydrogenation in the presence of copper or silver, we will get a ketone. Okay, for example, CH3, say I am taking a isopropyl alcohol. This isopropyl alcohol on dehydrogenation, you will get CH3, C double bond O, CH3 like this. Preparation of only aldehydes. Okay, few methods are there for the preparation of only aldehydes. In that, the first one is from acid chlorides, or else you can say acid halides. Okay, from acid chlorides, or C double bond O, Cl, acid chlorides. This acid chlorides on reduction in the presence of PD, BaSO4, okay, quinoline. Okay, this acid chloride, I will write here, acid chloride on reduction in the presence of PD, BaSO4, quinoline. Here we will get R, C double bond O, H. This is aldehyde. Okay, and here we have used this PD, BaSO4, which is known as Lindlar's catalyst. Lindlar's catalyst. Okay. And in this case, BaSO4 act as what? A poison. This is catalyst, and this is catalytic poison. Okay, the role of BSO4 in Lindlar's catalyst is poison. I mean, it is it functions as a poison. So BSO4 is a catalytic poison of what? PD. Okay. Now acid chlorides on reduction in the presence of PD, BSO4 quinoline or Lindlar's catalyst will get aldehydes. So in this reaction, C double bond OCl is becoming C double bond OH. So you have to add a hydrogen and you have to remove chlorine. So you will get a HCl here. And this reaction is called as, this reaction is known as Rosenmund. Okay, Rosenmund reaction. Then it is a named reaction, very important. So acid chlorides on reduction in the presence of Lindlar's catalyst produces or give aldehydes. This reaction is known as Rosenmund reduction or reaction. Okay. Now we will take one example for this. Acetyl chloride CH3 C double bond OCl. Okay, acetyl chloride on reduction in the presence of Lindlar's catalyst. Right here it is. Okay, PD, BSO4 and quinoline. Here you will get CH3 C double bond OH plus HCl you will get. And you know, this is called as acetyl chloride. Okay, the IUPAC name of this acetyl chloride is ethanoyl chloride. IUPAC name is ethanoyl chloride. Common name is acetyl chloride. Okay, as ethanoyl chloride or acetyl chloride on reduction with reduction in presence of Lindlar's catalyst will get acetaldehyde. Okay. Now I am taking one more example. If you take a benzoyl chloride, so this is a benzoyl chloride. Okay, this benzoyl chloride on reduction in the presence of Lindlar's catalyst, here you will get a benzaldehyde, CHO. So, and this Rosenmund reduction is used only for the preparation of aldehydes from acid chlorides, and this cannot be used for the preparation of ketones. Okay, so we are discussing only preparation of only aldehydes. Cyanides are nothing but nitriles, nitriles are nothing but cyanides. Okay, the function group of cyanides C triple bond N. Okay, from nitriles also, from cyanides also we can prepare aldehydes. Here it is R C triple bond N. Okay, this on reduction in presence of SnCl2, HCl and water. Okay, here you will get RCHO. Okay, and you know, this reaction is called as Stephen's. Very important, Stephen's reaction. And SnCl2 plus HCl is called as Stephen's reagent, and this reaction is called as Stephen's reaction, and this is called as Stephen's reagent. We will take CH3 C triple bond N. This on reaction with SnCl2 plus HCl and water, you will get CH3 CHO, acetaldehyde you will get. Okay, so if you in this process, in this reduction, if you use SnCl2 and HCl, then this reaction is called what? Stephen's reaction or Stephen's reduction. Okay, now from nitriles we can also prepare aldehydes by using another reagent, very important reagent, that is called what? Dibol or CN, or else you can write R triple bond N. This on reduction in the presence of Dibol H, very important. Okay, Dibol H, here also will get a RCHO, aldehydes will get. Now you should know what is a Dibol H. Dibol H is nothing but, okay, Dibol H is nothing but di-isobutyl aluminum hydride. Okay, you can write like this also, CH3 CH CH3 CH2, here it is Al, CH2 CH CH3 CH3, right, and hydrogen. So isobutyl hydride, di-isobutyl aluminum hydride is called as Dibol. Okay, it is a mild reducing agent. But whereas lithium aluminum hydride is a strong reducing agent, but whereas 𝗕𝗏 is a mild reducing agent, and that mild reducing agent or 𝗕𝗏H can be used for the conversion of aldehydes, for the conversion of cyanides into aldehydes. So, we can use this reducing agent for the preparation of aldehydes from nitriles or cyanides. We will take one example for that. CH3, CH2, Cn I have taken. This on reduction in the presence of 𝗕𝗏H. Okay, you will get CH3, CH2, CHO. Okay, propanaldehyde you will get. Next one is from esters. Okay, from esters also we can prepare aldehydes by using same reagent 𝗕𝗏H or C double bond O, OR dash. This on reduction in the presence of 𝗕𝗏H. Here you will get a mixture of R C double bond OH plus alcohol. Okay, we can also get aldehyde from ester. Okay, by the reduction using 𝗕𝗏H from methyl benzene. Methyl benzene is nothing but toluene. Okay, this toluene on oxidation in the presence of strong oxidizing agent, then it gives a benzoic acid. Okay, but actually if you want to prepare only benzaldehyde from toluene or methyl benzene, you are not supposed to use strong oxidizing agents. So, if you want to prepare benzaldehyde from toluene, we are supposed to use weak oxidizing agents. The weak oxidizing agents which are used in this process are CrO2, Cl2, and next one is CrO3 plus Ac2O, acetic anhydride. So, by using this weak oxidizing agent, we can prepare acetaldehyde from methyl benzene, or else we can say toluene. Okay. Now, methyl benzene or toluene on reaction with CrO2, Cl2, you will get this compound CHO, CrOH, Cl2. This is taken twice. Okay, and this compound on hydrolysis, okay, you will get benzaldehyde. Okay, and similarly we can use, by using the CrO3 and acetic anhydride, we can prepare a benzaldehyde from toluene. Okay, and next one is side chain halogenation followed by hydrolysis of methyl benzene or toluene. Methyl benzene or toluene on reaction with chlorine in the presence of sunlight, you will get CHCl2. This is called what? Benzol chloride. This benzol chloride on hydrolysis, this on hydrolysis, here you will get CHOH, CHOH. And you know that on one carbon, two OH groups cannot exist. This is a unstable compound. So, therefore, it loses water minus H2O. So, finally, you will get benzaldehyde, CHO. Okay. Now, so this about preparation of only aldehydes from nitriles, from esters, and by side chain chlorination followed by hydrolysis of methyl benzene or oxidation of methyl benzene.